Welcome to this webinar framed within the IBERUS Network of Excellence, in which we will provide a brief overview of the W3C WoT standards and their potential for integration in the eHealth sector. As indicated, the idea of this short video is to provide an introductory overview of these standards rather than detailed technical information on them. So we will first provide an overview of the IBERUS Network of Excellence and the relevance of integrating innovative technologies with a special focus on data. We will then provide a description of the main components and technical specification of W3C WoT. And finally, the benefits derived from application using IBERUS as a use case and some brief conclusions. So we hope you find it interesting. Let's start. The realm of health and promoting active aging has witnessed a notable influx of cutting-edge technologies geared towards enhancing the well-being of elderly individuals. But some of these technologies have trouble growing and bringing together information from patients to give a complete picture of people. So in this webinar, we will talk about some basic ideas connected to W3C web standards in health and social care. IBERUS is a network of excellence composed by 4 technological centers that work together to develop innovative health technologies that can help diagnose, prognosis, treat, and assist people with neuromusculoskeletal system diseases. More specifically, we have paid particular attention to clinical and in-home data related to stroke rehabilitation. As can be seen on the right hand of the slide, the final goal is appropriate decision-making based, in this case, on a set of clinical information, but especially produced and collected in the natural context of the person. In this sense, under an approach of interoperability and common data architecture, the capture, management, and exploitation of data linked to the different phases of the disease, ranging from diagnosis through medical tests to information took by monitoring the person, has been planned. Regarding the latter point, the information is captured by means of several devices that can be encompassed within the smart health data paradigm, including medical devices, electronic medical records, mobile applications, and wearable sensors. In this line, the use of new technologies can help in a number of features related to active and healthy aging. Thus, for example, the transition from the healthcare model of intensive care to person-centered care and prevention. So the new models aim to give the patient a key role in managing, monitoring, and guiding the process that preserves their health as the central axis of the real and effective development of so-called personalized medicine. Secondly, enhance the aging in place movement is another goal. The concept of aging in place refers to the ability of older adults to live independently in their own homes and communities for as long as possible by providing them with the necessary support and services to do so. And thirdly, access to objective information outside of electronic health records that explains a person's health status. It is estimated that around 60% of relevant information is recorded in sources that healthcare professionals don't have access to and, therefore, are not exploited with the consequent damages in terms of improving population health. This information about habits, their home, work, and/or leisure environments and behavior patterns with those environments provide really interesting information to define a complete and global vision of the person. In essence, incorporating artificial intelligence technologies and ICT tools that enable the use of this data to inform decision-making, add value to healthcare providers, and enhance patient treatments will be crucial for effectively addressing the current evolution of the healthcare model. In this context, it becomes important to promote healthy and active aging, which can prevent diseases and improve the quality of life of the elderly, as well as have a positive impact on the economy by allowing the elderly to continue contributing to society with their experience and wisdom. So, after this really brief introduction to our network of excellence, we would like to tackle different concepts related to key technologies and applications in health and aging related with W3C web standards. So, interoperability is essential for IoT devices and associated services to work together efficiently and to exploit the real potential of the data and technology ecosystem that make up our everyday lives. To this end, it is necessary to address challenges that are still present and that are of great relevance in the healthcare sector, especially those related to fragmentation of information at both entity and clinical department levels, the generation closely linked to the previous aspect of data silos where information is stored but not shared, and low interoperability between the devices used, making it particularly difficult not only to exchange data, but even to access them. So typically, in IoT scenarios, developers have to face a challenging situation. They have to understand a heterogeneous technology landscape consisting of a variety of IoT systems and services from different vendors and manufacturers. And this diversity includes variation in communication protocols, data models for payload data exchange, and security requirements. Thus, IoT applications are usually developed demanding a high effort applied to a narrow and specific use case. So, if not interoperability, during their lifetime, such applications are difficult to extend, maintain, or reuse, and obviously scale up. The Web of Things seeks to counter the fragmentation of the IoT by using and extending existing standardized web technologies. By providing standardized metadata and other reusable technological building blocks, W3C WoT enables easy integration across IoT platforms and application domains. So, these standards proposes three main axes around semantic interoperability, web protocols, and standards, the latter including both communication protocols and common architecture. Thus, Web of Things, or WoT, is a protocol-agnostic approach which provides a common mechanism to define how specific protocols such as HTTP or MQTT or Modbus can be mapped to the WoT's interaction properties, action, event abstraction. Another goals of the Web of Things are to improve the interoperability and usability of the IoT. So to this purpose, World Wide Web Consortium has established a collaboration involving many stakeholders over many years, including big players such as Google, Toshiba, or Netflix, among others. As already mentioned, interoperability standards in the IoT domain are fundamental to enable communication in an effective way between the services and components of the IBERUS network of excellence. Based on the benefits seen previously, the W3C Web of Things protocol has been the one chosen in IBERUS, both for its technical features and benefits and for the fact that CTIC is the W3C Latin chapter, thus having a relevant international position and a deep knowledge of this standard that facilitate their use and deployment. And thirdly, because the W3C WoT architecture establishes the basis for the Web of Things. Therefore, the W3C WoT architecture allows to wrap and embed devices using web interfaces to eliminate communication barriers between virtual and real worlds, providing a uniform and open interface that allows consumer entities to access the resources of a smart environment through well-known web technologies. Within the WoT ecosystem, the thing is the primary element. A thing can be any physical or virtual entity that has a representation in a WoT system and exposes functionalities as interactions. All potential functionalities of a thing are represented according to the interaction model, which defines three interaction types: properties, actions, and events. Properties are state attributes or values of a thing that can be read or written, like sensor values, configuration parameters, etc. Actions are meaningful procedures of significant timing that are triggered on the thing, such as printing a document or start an engine, for example. And events are instances observed by the thing in its environment that are transmitted to clients with an active subscription, for example, when a door is opened. Another main actor in a WoT deployment is the servant, which implements the building blocks and acts as a WoT client and/or server. So a servant is a software stack that implements the WoT building blocks. Thus, acting as a WoT client implies consuming and exposing things. So, a WoT servant is capable of thing-to-thing interaction, and it needs to implement both server and client requirements. Also, a protocol binding defines how the IoT things protocol messages are transported using a specific network protocol. A binding template is an entity that provides technical information needed by applications to bind and interact with the web services. A binding template for a specific provides a guideline how a client can activate each WoT interaction abstraction through a corresponding network-facing interface for that protocol, as far as WoT binding templates define concepts and vocabulary for the WoT things description. Another crucial element is the W3C WoT scripting API, an optional yet core component within the WoT ecosystem. It is part of the servant and plays a significant role by enabling developers to easily expose and interact with things, reducing the required effort. This API is commonly employed within gateways or browsers capable of running a WoT runtime and managing scripts, offering a user-friendly method for expanding support for WoT to emerging endpoints varieties and developing WoT applications. So, when referring to benefits, the W3C WoT has a particularly interesting role to play in the context of healthcare. Patient care devices and other healthcare and wellness-related assisted devices, such as monitoring systems, wearable medical devices, or remote assistance solutions, are playing an increasingly important role in people's well-being. These devices provide a large amount of valuable information for healthcare providers and patients, enabling them to make more informed decisions about treatment and disease prevention. So, integrating these devices with web delivers several major benefits. Firstly, the web is a meeting point for multiple domains, meaning that devices can easily communicate with each other and with other services on the web. This can significantly improve coordination and efficiency, which in turn can lead to better patient outcomes. In addition, web integration can enable new use cases and applications for health-related devices. For example, data collected by a health monitoring device can be used to detect patterns and provide personalized recommendations. The data can also be used for research and improvement of healthcare systems. Another important benefit of web integration is the breakdown of the highly complex and property barriers that often exist around health-related devices. Many devices are proprietary and use customized communication protocols, making integration with other devices and systems challenging. So web integrations can help overcome these barriers and enable interoperability. And finally, this is an open standard which promotes open science, so contributing to gather new evidence when making and carrying out research. So based on those previous benefits, here you can see a comparison based on the results that we have gathered when applying these web standards in IBERUS as a use case. So on the left side, you can see the situation when not using W3C web standards and the challenges that you need to tackle, and on the right side, the potential benefits that we have found when using these standards. So the question is, what could be the status of IBERUS without this protocol? So as said, on the left side, we can see this conclusion. So firstly, data could be collected independently from each data source and each device. So we will have a bunch of data from different sources in different files to be compiled. Also, data should be dumped into the cloud to be processed and exploit all the data that we have gathered. Also, cloud sends to electronic health records via several different protocols. So we will need to implement different interoperability protocols communications. Also, there is a clear limited application by using this approach, because this would be only applicable in certain scenarios. And as you can imagine, considering these challenges, it is really complex to deploy multiple devices in a real ecosystem. But using WoT standards, it is possible to use IoT in real scenarios, so gathering a really high ecological validity and gathering real-world data. We are not only enabling interoperability but also promoting security and privacy, as far as WoT provides guidelines for the secure implementation and configuration of things, and obviously security and privacy should be considered in any system implementing W3C WoT. And also, it allows the integration of third-party data sources, provided a clear, continuous sustainability and scalability of the solutions deployed. So the benefits and impact on making decisions around health are clear, as well as tapping into the huge volume of data that we all generate more and more in our daily lives. As conclusions, web technologies have developed significantly and are now ready for work in any field, including obviously healthcare. The direct capture of information allows raw data to be exploited, providing comprehensive and unbiased initial information to improve decision making. WoT is clearly scalable, and there is a solid development of the network of things, which guarantees the sustainability of the developments. Also, W3C is web, and the web is in everyone, increasingly more present. And WoT presents an easy deployment and scalability in a relevant and high impact area such as healthcare. When not using this kind of standards, we need to keep in mind some risk. Firstly, that right now there are too many standards that complicate communication tasks. And until the standard is adopted or there is consensus with the manufacturers, it is necessary to use the SDK proprietary, which may limit the above benefits. So overall, to conclude, the set of benefits is obvious, with a solid context that guarantees an adequate implementation in a sensitive field such as healthcare, with a cost-benefit ratio that is also extremely positive. We sincerely hope that whilst this has been a brief introductory approach, you have found it interesting. Nonetheless, we encourage you to consult our work on the web iberushealth.org. Thank you so much for your attention and have a nice day.